This tutorial is going to address one of the most important concepts in Grasshopper, lists and data structures. This topic is complex and challenging to master, but this tutorial will outfit you with the basic tools to understand and manage lists of data. In Grasshopper, data can be passed around from component to component in one of three forms: as a single item, a list, or a list of lists called a data tree. In a list, items have their own addresses called indices, which count from 0. So the fourth item is at index 3. In a data tree, each list, called a branch of the tree, has its own more complex address called branch paths that look like this. Let's go over to Grasshopper and see how this works in practice. So what I'm going to do is just create a list using a component that I don't think we've seen yet called series. So I'm going to go to the Sets tab and Sequence. This is a bunch of tools for creating sort of lists or working with lists. And series component will create a list of numbers. I'm also going to connect a panel to the output so that we can see the data that's coming out. Remember that sort of a panel is a useful tool to visualize the data coming out of any node. So I can see that I'm getting a list of numbers. This component takes a start value, a step size, and a count, which I can see by hovering over each one of these inputs. And if I manipulate this by, say, creating a slider, I'll set the max value here to be something like 100, and I'll set it to be slider type integers. And again, I'm just manipulating this slider by right-clicking it and changing the values over here. You could also double-click. I can change the number of values. I can change, and I'm just copying and pasting there. I can change the start value. So even as the data changes, the indices will always count from 0 to kind of the last item in the list. So a panel is a really useful way for us to kind of look at this data because in addition to showing the value of the data, it also shows the index. So components in Grasshopper expect data in certain forms. So I make a sort of general categorization of three basic kinds of components in terms of the sorts of data that they take in and spit out. So we're going to look at a component that we've already seen before under the curve tab. And remember that if yours shows text, you might see the word curve. And I'm going to grab circle, the one with the orange background. And again, I think I've said this before, but it's really useful to hover over the various parts of the component in order to learn to read what it's asking for. It's just like kind of the hints that a command will give you in the Rhino command line that tell you what you need to do. So this says base plane of circle, radius of circle, and outputs circle. So what you'll notice is that the little header up at the top where it says plane P, radius R, circle C, none of those say list or tree, which tells me that these just expect items. So if we create a circle here by providing a base plane for the circle, which right now I'm going to go to vector plane and grab the XY plane, which is just the world origin, and then supply a radius. And here I'm going to copy my slider from before with copy paste. What I get back out is a single circle. So with a component that is what I call a one-to-one component, meaning it takes items and it returns or outputs items, then you get sort of the same number of things out as you put in. Now, other components are what I would call one-to-many. So if we go to the curve tab, we've also seen this one before, I think, under division, divide, curve. This component, if I hover over it, is looking for a curve, a number of segments, and this Boolean value, which we won't worry about. But when I hover over the P output, you can see it says points P as list, which is an indication that this is going to return multiple values for every item that you put into it. So if I use this very same circle that we just created by clicking and dragging from here and plugging it in, then what you'll see if I add another panel to view the output, is that we've got a list of values coming out, each of which has an index associated with it. So this is what I call a one-to-many component because it takes single values as its inputs, but returns a list as the result. Now, there's a third category called many-to-one. And again, this language is like something that I've made up. It's not sort of official terminology, but I find it to be helpful in conceptualizing the way these things work. So if we go back to the curve tab, and this time we're going to construct a polyline. So we're going to go to the spline tab and grab the polyline component. And if we, again, read this component by hovering over its inputs, we can see that it's looking for vertices as list. And in this case, the sort of Boolean toggle here is just an item access. But if it has any lists on the input, then I consider it to be a sort of many input component. And then the output here is a single polyline, which we can see because it does not say as list in the little hint. So if I plug this list of points into the polyline, then what I get back out from the output is a single polyline. So we've taken a list of multiple values and retrieved a single one. It's also helpful here to familiarize ourselves a little bit more with some of the preview capabilities in the Rhino viewport. So I've got a maximize perspective viewport over here. You'll notice that when you highlight objects in the Grasshopper canvas, they turn green by default in the Rhino viewport. There's another display mode that I find really useful when I'm kind of stepping through a definition in order to understand what's going on, which is this little green button over here, which says only draw preview for selected objects. When I do this, preview goes away for everything that's generated in Grasshopper, all of our virtual geometry. But as soon as I select something like this plane, you'll see that it shows up in the preview. When I click the circle, I see the circle. When I click divide, I see all the points that I've created. And when I click polyline, I can see the polyline that's being passed through those points. Incidentally, if I want to close this polyline to make sort of a polygon figure, then I can use another sort of base input component, which lives under params input, called a Boolean toggle. And a Boolean is just a fancy name for a yes, no, or a true, false value. And in this case, I can tell that this is asking for a Boolean value because of that little icon. You can see the black hexagon with a little half circle that's half filled in it. All of those type icons correspond to parameter types. And params is short for parameters. And all of the parameter types that are available are up here under geometry and primitive. So if I'm not sure what something is asking for, like I can see this one has a 7 in its icon, I can go up to primitive and find the one that has a little 7 in its icon to see that this is asking for an integer value, which is essentially a round whole number. And in this case, it's asking for this sort of half-filled circle, which is a Boolean value. And a Boolean toggle is a quick way to input a Boolean value. And with this polyline selected, you'll see that if I turn this to true, it'll connect the last dot. So if I hover over this, it says close polyline. And so with that value set to true, it produces a closed polyline. So we're going to return to this example in just a little bit. But I want to talk about what happens when we start to plug in multiple values to components that expect single items, for instance. So I'm going to make a copy of this whole arrangement with the plane, the radius, and the circle component, and this panel so I can see what I'm getting. And what I want to do is, instead of supplying a single value, I want to supply multiple values to the circle component. So there are a few ways that this might happen. One is we might have a list of numerical values to cover the radius. So we've already seen one way to create a list of numerical values is under set sequence series, which creates a list of numbers. And if I plug this into, let's just preview its result first. We've got a 0 to 9, and if I plug this in, you'll see that I get back a list of circles. One of these is invalid because it doesn't make any sense to have a circle of radius 0. So instead, I'm going to take this slider and I'll lower its value a little bit, plug that in as the start value so that we start at 7. And you'll see that for every input value in this list, I get a corresponding output piece of geometry. So this is really one of the critical pieces of Grasshopper, and the power of it is that in the same way that you can create sort of single things, you can create multiple things just as easily. So this is where it starts to become a more efficient way to work for certain kinds of modeling scenarios than Rhino would be, because you can create things, sort of many things at the same time, and have a lot of control over them. So I can see the effect that maybe manipulating the step size of this would be, and I can start to dynamically change this list of curves. Now, there's another scenario by which we might have multiple circles come out of this. I'm going to remove this wire. I haven't shown this yet, but if you hold down Control when you drag from one output to an input or vice versa, it will disconnect that wire, or you can always right-click that input and choose Disconnect. So this has a default value of 1 for the radius. We can see we've got a little tiny circle. But this time, I'm going to create a list of points instead of a single plane as the base point for this circle. So I'm going to grab one of these point components. This is a parameter which can contain data. And I'm going to right-click it and choose Set Multiple Points. Now, this makes Grasshopper disappear, and it actually fires up a sort of mini Rhino command, which is asking for the locations of the points that you want. Now, it's very important to pay attention to what it's asking for here, just like any Rhino command. There are several types that it can ask for: coordinate, point, and curve, and yours might default to point. But in this case, we want to click coordinate so that we can just click. Otherwise, it would be asking us to select actual point objects in the Rhino space, which we don't really want at this point. So with coordinate selected, I'm just going to click a whole series of points. And even though it's drawing lines between these to indicate the order, those lines don't really exist. And when we're done, we'll hit Enter. And now, if I plug this into a panel, we'll see I have now a list of 13 points. So if I plug these points into this circle component as the base point, it creates a circle at each one of those points. So you can see that whenever you have a one-to-one component and you supply multiple values into it, it produces a corresponding list of values as output. Now, the final scenario, and this is where you really have to kind of keep track of the lists that you're feeding in as input, would be if we wanted to create multiple points or multiple circles in different locations with different radii. So we know that we've got 14 points in this list. So if we create a list with 14 numbers in it, and I'm going to do that by just, this is a nice shortcut. If you double click and type a number and hit Enter, it will create a slider that is pre-populated with the value that you specified. You can also use a panel for this purpose. So could also drag a panel down and type 14 and plug it in. Those are just two ways to kind of input specific numbers. I tend to use a panel where a number is not going to change very much, and a slider for something that I might want to alter on the fly. But it's really up to you. So I've now got a list of 14 values counting from 0 to 13 in the index, and I've got a list of 13 points. I'm just going to copy and paste this panel so that I can see those points, and I'm going to plug them in. And if I click on circle in order to visualize the results or the geometry being generated by this, and here I might make these circles a little bit smaller by changing the start value and changing the step size. You'll see that it is matching up each point with each radius. So because this is a one-to-one component with sort of item access on all of the inputs, it's going to go take the point at index 0 and the radius value at index 0 and output a circle at index 0. If I go down to 9, I know that circle at index 9 on this list is going to be located at the point at index 9 with the radius at index 9. So it's very important to keep track of the way that you're matching lists up. And typically there are really only 3 possible scenarios, and we just went over all 3 of them. One is that you have one value and one value. The other is that you have one value which is being matched or replicated against n values, whatever that value n is. In our case, it's 14. And then the third scenario is where you have n matched with n. The one thing you almost never want, it's possible to do, but it's almost never useful, is to match n with m, or with some other value. It will work if you do this, and I just want to show you what happens, because sometimes it produces a particular kind of visual result that you can recognize as being a result. So you'll see that I only have 5 values here, but I have 14 values here. And when I match these up, what it does is it matches up the first one, the second one, the third one, the fourth one, the fifth one. But then when it runs out, you can see here, because it's indicating the radius, it just uses the last value over and over and over and over and over again until it's finished out the other list. So that's what's called longest list matching, where essentially it just repeats the last value on every list until it's gotten through the longest list that's being provided. So what I'd like to do now is return to this example, where we have our kind of simple circle, divide, polyline scenario, and kind of merge it with the last thing we saw, which is what happens when you provide multiple values into the input. So this is a one-to-one component, and we've already seen that if we provide a list of values, and here I'm going to show you another way to create a list of values. We're going to use a panel again, and I'm going to type 5, 6, 7. I'm using enter in order to separate those lines. And then this is a critical part. If you right-click and click multiline data on the option, now it will actually output a list of values, where before it's outputting a single value that includes those enter characters or carriage returns. So if I want to supply a list by manually entering it into a panel, I have to make sure that this multiline data option is disabled. And if I plug this into the radius, then I get 3 circles instead of 1, which is to be expected. That's what we saw down here. But let's take a look at this. There's one thing I want to point out right away, is that the wires in the definition change based on what kind of data is provided. So this wire indicates that there's only one item passing from this output to this input. When I plug in a list, it uses this double line, which indicates that multiple values are being provided. And here also, multiple values are being output. So what happens when you take a one-to-many component, like this one, that takes in a single item and outputs a list? The answer is a third category, which I mentioned at the beginning of the tutorial, called a data tree, or a list of lists. And that's what this sort of fat dashed line, double line dashed line, represents. So I'm going to take a big panel here and expand this all the way down so we can see what we're getting out. So each one of these gray headings indicates the beginning of a new branch or a new list in our data tree. And for every original item that we had, it's going to output a new list and gather each one of those lists into a tree. So this has taken these 3 circles and divided each one of them, but kept the results of each operation separate by branch. So whenever you're dealing with a one-to-many component, if you provide multiple items in the input, you will get a tree as output. So it's just a way of kind of knowing where data came from. So I can see by looking at the branch paths when I hover over this output, you can see that it says 0, 0, n equals 10, 0, 1, n equals 10, 0, 2, n equals 10. And those branch indices there at the end correspond to the indices of the input that you fed in. So I know that circle at index 2 in this initial list is going to give me results in branch 2 in the output. So why do we care about this? Why would we even want to keep these separate? What if we just want all these points? Well, the reason we want to keep it separate is in the scenario where we have a many-to-one component, but we want it to produce multiple results. So the polyline we saw before is smart enough to treat each one of these lists separately. So even though it takes in a list of values and produces a single item, when you give it a tree, it treats each one of those lists separately. So that means that we're getting 3 separate polylines out of this. If we didn't have this distinction, and in fact, old versions of Grasshopper did not have this distinction and you just had items and lists, then it would be literally impossible to create multiple polylines at a time. You would have to do it by copying and pasting components, which in general I don't think you should have to rely on. So that's sort of a quick tour of the very, very basics of this kind of list behavior. And if this was pretty quick, I would really encourage you to open up there was in one of the example files under lists, list examples should cover all of the cases that I just talked about with some explanation. So feel free to peruse these. This should be everything that I just talked about. And the last thing I want to talk about in this tutorial is how do you manipulate lists? What if your list is in a structure that doesn't correspond to what you need in order to do the thing that you're trying to do? And I know that's very abstract, but I promise that as we go into further tutorials, we will see the application of a lot of these concepts. So this is just sort of laying the foundational groundwork. So the first piece of that I want to show is this one thing here. And so this is just like the scenario we set up. We've got a list of values producing multiple circles, which are producing multiple lists of points, which are producing multiple polylines. And then what we retrieve is a series of lists, each of which has only one item. So the scenario where you've gone from multiple lists generating single items, you may want to push this back into a list so that this list of polyline curves corresponds with this list of circles. So you can see that I've got a single list of 10 circles from 0 to 9 over here. But over here, I've got actually 10 lists, each which only has one item. Remember that the dark gray header represents kind of the start of a new list. So this operation, shift paths, is essentially a way to pop a layer of hierarchy off of your list. This may seem super abstract. I'm going to go over it again in a second. But this is a really critical and useful component when you're manipulating data structures, in particular data trees. So this says, take that last index, which indicates where this came from, and pop it back off of the list hierarchy. And so that means that we go back to 0, 0, 0, 0, 0, 0, and anything with the same branch will get combined. So now all of those have been merged back together into a list called 0, 0, and what was their branch index becomes their item index. So let's go over a few more examples about this. For this one, I would recommend that you actually start with the file rather than trying to build on the fly, because I've set up a few examples that indicate how all of these things work. So before we get into tree stuff and going back to this shift paths concept, I want to just look at some of the most simple list operations that you might want to rely on. Here's another component called sequence, which is just like series, except it creates letters instead of numbers. So I'm going to use this as my base list. And one component that frequently comes up is list item. So under set list item, if I hover over its inputs in order to read it, I can see that it takes a list as list, and then an index as an item, and then returns a single item that you requested. So when I have provided this list of letters, and I say, all right, I want the item at index 5, then it's going to go look in this list, find index 5, get the item F, and then spit that out as the output. Now, I can also provide a list of indices if I want to, and I'm going to do that by just copying and pasting this slider a few times. And this is a trick I haven't shown you yet. I showed you before how to use merge to construct a list. You can also shortcut that by holding down Shift when you connect wires and have multiple wires go into a single input and automatically generate a list. So because all three values of these are 5, it's just going to go get F 3 times, but if I change the values that I provide, it's now going to go retrieve the corresponding values, F, I, C, in the order that I've supplied them here. So it's giving me the items at index 5, 8, and 2, which are F, I, and C. List length is another useful one, also here under set and list. And all this does is return a single number, which tells you how many items are in the list. Merge, I think we've seen before, which takes 2 lists or even more if you want. If you zoom in, you can hit a plus button in order to add or remove inputs, so you can merge as many lists as you want. A lot of components in Grasshopper function this way with a zoomable user interface. And this just appends one list onto the end of another. So you can see all my letters from before are now getting a series of numbers added at the end. Sort list is a useful one when we're working with one data set, but we want to understand it or reorganize it according to another data set. So here I have a list of numerical values, and I have a list of text, which are the names of those numbers. And with the sort component, I provide a key list, which are actually the values that it's going to sort, and it's going to sort them numerically. But then I can also provide another list to sort along with that list. So here, these values are out of order in terms of their numerical value. And the key list output will reorder those so that they go from smallest to largest. But it has the effect of also sorting whatever list I provided here optionally, so that these values also get sorted. If I tried to just sort this text, it wouldn't know what to do because these don't have readily understandable numerical values that the component can parse, but these do. So lastly, I just want to go over a few more of these tree operations. We already saw shift list, which I think is a really important one. You can ignore most of this. This is just how I'm creating a structured data set, but let's take a look at this data set to understand what we're getting. So we've got a data tree that has a more complex structure than I think we've seen before. So there's a list called 0, 0, which has A 0 through 0 to A 0.9. And then the next list, 0, 1, has A 1.0, 1.1, etc. And you'll see as I go down that this second index increases with the kind of second place in this text. And if I go further down, where the first index increments to 1, then I'm starting to deal with B. So this is tracing kind of the source of the data. So the first place in this data set corresponds to the first index, and the second place corresponds to the second index, and the third place, the sort of the thing after the dot, really corresponds to the index of these values. And this is just made up data. The actual content of this data doesn't matter. I'm just using it to represent a more complex nested structure. There's a component we haven't seen yet called the param viewer, which you can get to under params, util, param viewer. And this is a way to investigate the tree that you're working with without looking at its values. So I can see these are the 40 branches that I have from 0, 0 all the way to 3, 9, each of which has 10 values in it. And there's no reason why these couldn't have different numbers of values. And there's another nice thing about the param viewer that some people really like as a way of kind of conceptually understanding a tree, which when I double click, I get a diagram of the tree. And I'm going to expand this so we can really look at it. So if you think about it, we've got these 4 base branches, which correspond to 0, 1, 2, 3, which correspond to the first letter in these data sets, so from A through D. Then each one of those 4 base branches splits into 10 new branches, which is going to correspond to each one of these lists. So we've got A0, A1, etc., 0, 0, 0, 1, 0, 2, 0, 3, etc. And then these little orange nubs at the end represent the actual lists of values contained within each one of those. So one operation that we frequently have to do in order to get lists to work with each other is what's called graphed tree. And you can graft a tree using the graphed component from sets tree graphed tree, or on any input of any component, you can right-click and choose graphed, which has exactly the same effect. So if we look at graphed tree, you'll see that what it's done is it's put every item in this original list into its own list. So where we had 40 branches before with 10 items apiece, we now have 400 branches, each with 1 item. It may seem really abstract right now, like why would we want to do this? But I promise as we go further through the tutorials, you'll see the scenarios in which we might want to apply something like this. So if I double click, you'll see the complexity of this tree has grown considerably. We still have our original 4 branches, each of which splits into 10, but now each one of those splits into 10 because we've grafted. We've said, put each item on this list onto its own list. And now each one of these nubs only has a single item in it. Now, shift paths, which I already showed you, does the exact opposite of graph. Rather than putting each item onto its own list, it takes a level of hierarchy off of the list. So where before we had sort of A0s in their own lists and A1s in their own lists, when I do a shift paths with a default offset of -1, then all the A's go back into their own branch. One item has popped off of the list hierarchy, which is this last index, so that all the zeros get merged together. And we wind up back with 4 branches, which just correspond to the A's, the B's, the C's, and the D's. Lastly, flatten is like a nuclear option when it comes to shifting paths and eliminating list hierarchy. So what this does is it just takes any data and merges it all into one list. It doesn't care anything about the structure that you provide it. It just smushes everything down into one list. So you can see this is just one list with a branch path of 0 and 400 items in it. So this one is also available when you right-click an output. And there are many scenarios where you might need to do this, especially when you're starting out. But in general, you can achieve most of what you want to do by just using graph and shift paths to kind of pop an item off the end or add an item to the end by sort of increasing the hierarchy or decreasing the hierarchy in a relative way. So we'll see lots more examples of this as we move on through the next set of tutorials.